Okay, so that is the, I suppose, the easy part. You know, getting all the main components into your box. You know, plenty of room around them to work. You can pull these plugs out and put wires on them, but I've left plenty of room in there to get a screwdriver in and actually do it in situ. So what I've decided to do is this umbilical cord now is going to have connectors in the top section up here. Oh, these are the connectors. These are aviation plugs. Okay. Now I've got, let me see. There's 2-pin, a 5-pin. Now that's for the, I'm using that one for the spindle, and also I'm going to run an earth through that and have a couple of spare connections. And for the stepper motors, 4-pin. So you've got a male and a female. It'll only go in one way. There's like a locating lug. There it is there. So it'll only go in one position. And now it's easier to put the wires on these when they're out of the unit. So what I'm going to do now, and this is the back panel, alright, so it slides in the back. So I'm now going to put all the holes in along here, and for these to be mounted, but I'm going to solder the wires on these first out here on the bench, and then, you know, put this in, assemble these plugs in, and then cut the wires off to the absolute length, and probably color code it with a, so I know which one is what. And I've actually written on the board here X, Z, Y, and Y's slave. So you know, you need to code these things so you don't get confused, because you know there's going to be what probably 25 to 30 wires, individual wires going up, and they've all got to be connected correctly, otherwise some part of it or another is not going to work. Okay, so having got all our major components into this electrical cabinet, which is, I'm sure you can tell, is an old computer, I've just made up this back panel and put these are aviation connectors. These are the ones I would recommend using for a CNC build. Of course, these are the cables. Now, I label all my cables, makes it a lot easier to you know, connect up if you know what cable is what, because you know basically all the cables are black and they look very similar. Plus I write on here exactly where they're going, so you know there's no mistake. So we will now put this in or on. That fits in there quite nicely, and it's quite organised. At least it will be. Okay, it's been a long time getting this far, and it may look complicated in here, but really it isn't. It's quite methodical actually. So we will open it up and bring it a bit closer so you can see. That's better with a bit more light, I think. Okay, so this is the SMC. And here I have the variable control for the spindle, and if I just pull this wire out here, I've just stuffed in here. Now here, I've taken out the bridge that was on the power supply. If I can turn that a little bit. There's a bridge here that you can take out and put a switch on, so you can switch this unit on and off. Okay, which is what I want. I didn't want to rely on the variable control or rheostat to, totally switch it off. I wanted to totally isolate the spindle, switch it off. So that's what I've done there, and I advise you to do the same. These three here, mark every wire if you can, and I'm going to show you in a minute what to do if you have a wire that's not marked and goes into a bundle like that. I'll show you what to do. So X, Y and Z there, this is coming from the limit switches, which are not fitted yet. So I'm just going to poke those out through there, out of the way, because they're not going to be connected up for a while. This big fat lead here, that one is going to, let me see, this large connector back up here, that's the supplies the spindle. I've also got an earth lead there, that green one, that is going to be supplying an earth to the actual CNC router itself. And of course this earth is going to the chassis of this metal box. So everything is earthed. What else have we got? Okay, so I'll just go through these leads here. And look, I've left them quite long because I want to be able to open the door right out. So they have to be able to go out there. So, when they're attached, they're going to be bundled up and zip tied like this, and there will be an area here. So when you close the door, it folds in like so, and doesn't hurt. Okay, this little blue lead here. Okay. This is spliced at this point into 4 other leads. It's soldered and taped with insulation tape, and then that supplies 5 volts to each of the drivers, and this gets connected up to the 5 volt supply on the back of the SMC. This cable here, this is the 12 volt from this DC converter here, power supply. This is going to supply the 12 volt to the SMC, but what I'm going to do is split this like this. Okay, so this is the positive, this is the negative. Negative goes straight into here. Positive is going to go onto one side of this switch, and I'm going to put a lead then from the other side of the switch up into the 12-volt supply here. So I have another isolating system. This time it's on the 12-volt circuit. So I can switch this off if I wish. Okay, so that's those. So you see, it's not really complex. It's quite methodical, really, honestly. Now these three are the signal. Okay, pull and directional, pulse and direction. Okay, for the X, Y, and Z. All right. Now I know I have 4 drivers, but 2 drivers are going to operate together because I have a left and a right, or should I say I have a Y-axis and a Y-slave axis. Okay. Now they are at the bottom here. So what I've done with this, I supply one of these supplies one of these drivers, and I've looped over and supplied the other one as well, so they get an identical signal. Okay. Now this is a homebrew little CNC router. Okay, it is not an industrial machine. It's not going to be used as an industrial machine, and I know through personal experience, whatever work I put it through, it's not going to lose a step on, you know, very, very rarely will it lose a step on the 2 Y drives. So what I will be doing is every time I start a new job or fire the machine up, I will be asking the SMC home the unit, which will put the spindle top of the stroking Z far over to the left as you're looking at the machine, and as far forward as it'll go. So when it has done that and registered the machine home, I can then quickly just put a rule, okay, or a vernier on the slave axis and just measure exactly where it is, compare it with the other side, and I'll know within 10th out whether they are absolutely parallel or not. If they're not, it's a very, very simple solution to level them up. Okay, and I'll show you that when the time comes. Okay, I'm going to show you what to do now if, like in this case, I really don't have a clue which one of these 3 wires goes to which driver. So with your little multimeter, just come down here, select 200 ohms is fine. So it's an open circuit at the moment, and I think you can see that registering. Yeah, you can. So if you notice, it goes to 0, closed circuit, open circuit. Okay, closed circuit, open circuit. So what we're going to do is signal, there's signal. I'm going to have 3 pairs of hands to do this, I think. How easy can I do this? I'm going to take this long one. I'm going to stick it in there. If I can hold that. Just watch the meter. So this is, oh, right first time lock. Okay. Put it on this one over here. Nothing. This one. So I know that this lead is connected to this one. So we'll mark that one. And that's the Z axis, because I've actually got Z, X, Y and Y slave written on the underside. And label it, so now we know exactly what that one is. And I'll do the rest of these and I'll come back to you in a minute. Okay, so this is the loop wire from the switch to the positive, which is here. Okay, that's on there. This is the positive feed. Goes on the top one. And this is the negative or ground. So, you know, I've connected everything up here. I've got the limit switches connected here. I've got the positive and negative feed coming in here to feed the SMC. I've got the earth, which is the green one there. The little blue one here, that's the one that feeds all the drivers with the 5 volt. And I've got X, Y and Z connected into the controller, and I've actually got, I've only got 3 coming out because I've got the Y and the Y slave connected up together here. So I've got 1 feed on the Y circuit coming out of the controller, feeding the 2 with a step and direction, which is fine. I have used that before, no real problems. And I'm only operating 3 limit switches, one on the Z, one on the Y, and one on the X. Although I'm running 2 stepper motors and drive systems on the Y, what works for me anyway, guys, this is not an industrial machine, it's a little bit more than a hobby machine then, is you home the machine, and then when you've homed the machine, all you do regarding the Y is just take a measurement of the slave Y axis and make sure that that's, you know, exactly the same as the other side, and if it's not, you just sort of compensate for that to bring it up in line. Not very often you have to do that at all because it just doesn't lose steps. Okay, so time to switch it on, I suppose. I have got a switch here, actually, to switch the SMC on and off. Haven't got it connected up yet because I wanted to make sure everything works. All blue lights on here, green light there, green light up on there. Everything should be up. There you go. Of course, this is the umbilical cord to the router is not finished. That'll be the next video where I actually connect it up to this via the umbilical cord, and of course none of this is connected to the separate motors up here. You know, I'll sort of do a little bit of videoing on that. So the next video we will have the MIDI CNC router moving under its own steam via the SMC, and we will do. I'm not going to do a great deal of calibration. What I want to do with the next video is just get it working, get the homing switches working, and put into the SMC controller the dimensions of this little router. They don't know exactly what they're going to be, but I know within you know, a couple of millimeters what it's going to be, but I want to know exactly what it's going to be with the limit switches on, connected and working. And it is only at that point, when you give that information to the controller, it knows then its window of operation of that machine. And it's only at that point, when you give it all that information and it homes, it will not give a trace on here. Okay? Because it won't know what the picture is. If you know what I mean, you won't know what that machine looks like, how big it is. So it's only when the limit switches are on, connected, working, it homes, and you put in to this machine the values of the X, Y, Z coordinates, soft limits as well, sort of putting in the soft limit information. Then it'll do a trace on the full screen if you want it. Alright, I do notice on some of the comments on some of the, some other videos that, oh, it doesn't show a trace and all this, that and the other. And, well, it's not true, because it does. Another thing too, there's a lot of misconception about the G code. Okay? What I can tell you is Carveco will write G code that you can put straight into this and operate it without manually going in and changing any of the code. Okay? And having said that, below this video, in the video description section, so you'll have to expand that, you will find a 5% discount code for all of the Carveco products. Alright? So that's Carveco Maker, Maker Plus, and the main Carveco program. Whether you get it monthly, yearly, or buy it outright, it's 5% of everything. Alright? And additionally to that, I do notice people have sent me emails saying, oh, your code's not working. Well, it works with the address that's just underneath it. Alright, just underneath my code, you will see a Carveco address. It's a special address, and that takes you into the main to Carveco themselves. It's not a reseller. It is Carveco themselves. Alright, direct in the US. So that's why you have to use that link. Okay, use that link, no problem at all. You will get your 5% off. Alright? Okay, well, I'm happy. This is all going. It's not. It may look a mass of wires and complicated, but it's really not. It's really not complex. It's quite methodical, actually. So don't be afraid of it. So If you've liked the video, please press like and subscribe to the channel. That's always a help. And if you would like to pop along to my Patron pages, and if you would like to become a patron, that would be a fantastic help, because it is the patrons behind this channel that keeps it going. Since COVID came in January or so, and I think it was the 1st of January, the Children's Protection Act came in on YouTube. You know, it's pretty well destroyed a lot of us. All the content creators, you know, we've just taken a huge hit, and it's nearly destroyed us. So it's the patrons that have allowed me to keep going, and I would like to take this opportunity to thank them very, very much. And I hope I can continue to make videos like this for you, and projects, and show you everything about them. So again, I hope you've liked the video, and well, till the next video, well, I suppose it's bye for now.